so we're here in Seattle, and I'm here with my colleague Ned, and we're going to have what we could probably say is a fireside chat about Tuxera, about what we found since we've been here, because we joined around the sort of same time, and some of the things that we've discovered within the software and what we can do with it. So, Ned, it's good to see you. I'm glad to be in Seattle, and we're in this room full of maps. Maybe you could talk about a little bit where we are.
Yeah, so we're in this excellent old hotel called the Arctic Club, and it's in downtown Seattle. It was founded by a bunch of rich guys, like most clubs, who wanted to have a place to go hang out and smoke cigars in 1910 or whatever.
Yeah,
and it's from the gold rush, so all the money about it came from the gold rush up in Alaska, but no one who owned or built or was in the club mined any gold. They just sold picks and shovels to people. It's the real way to get rich,
yeah.
Right?
Yeah, so we're going to have a little chat because we've both got very different backgrounds.
So I am the Enterprise Storage Technical Officer at Tuxera, which means I'm in charge of owning the Fusion product line and building it for the future and maintaining its quality for the present. And really just all things SMB. The reason why I'm here is because of SMB.
Yeah.
Anybody who knows me from my time at Microsoft. I was there for 20 years, and for the last 13 of those years, I made the SMB protocol for everybody in the world to use. I made it for Windows.
Mm-hmm.
It's an open protocol specification, so anybody could go and make their own version of it and such things. And so I did compression and quick. I worked on RDMA, SMB Direct, multi-channel, a ton of security stuff. People really know my name from the work that I did to get rid of SMB, because SMB won.
Oh, yeah.
The SMB won protocol to stamp it out, and that's what I spent a lot of effort doing over a few year period, and was successful for the most part. Anyway, SMB came around as the real SMB won, starting properly in the early NT days, and it's gone all the way to SMB3.
My background is completely media. So starting a long time ago. So I started off in DTP, the old days of digital printing. So moving from sort of line type presses and things like that over into digital printing. So early days of Quark and PageMaker and things like that. So it was a long time ago, and I started my career working on Mac 2s and Mac 2 CIs. So it's been very much of a Mac background all the way through.
Of course.
And that kind of transitioned me from DTP into media, and then into a company that was developing NAS solutions. So originally it was a video reseller, and we were installing SAN. So I'm familiar with XSAN and StorNext and that kind of environment, and TigerSAN, and then moving into network storage, which in 2009 was no one was really doing it. And if you said, you're going to be editing from a NAS, people used to laugh. But we managed to get some pretty good performance out of that, a lot of performance. And that led us down the route of that video production side of it and multiple connected users, because it took us away from SAN, which was complicated, expensive, and challenging to run. And then in my latter years, I went to work for a large German company. Those who want to scroll through LinkedIn can find out where I was. But whilst I was working there, I went in to manage their storage system. Unfortunately, I was only there for about a year before they decided they wanted to move away from hardware and into a software platform. And bearing in mind my storage servers were the biggest use of hardware going, it was cast first on the chopping block. But that's where I discovered Fusion, and I discovered Tuxera. Because we were using Samba within that storage, and it was proving problematic for point-to-point storage, point-to-point performance. And that's when we looked at Fusion, and I realised what it could do. And it was when I was there that we kind of broke this magic barrier of 5 gig a second over SMB to Macs. And of course we can do it on Windows because you've got RDMA Direct. But on Macs, it was always hovering around sort of 2.5, 3 if you're really lucky. And from there, I ended up at Fusion, at Tuxera, with Fusion. So 2 different sort of routes into effectively now us kind of sharing the Fusion product, and me from marketing and workflow ideas and pushing the product and where it can go, and obviously you from all your experience. And Tuxera's been interesting joining the company. It's a cool company.
It is. I heard about Tuxera and SMB,
Mm.
like around 10 years ago. They started showing up we'd have these plug fests at the Storage Developers Conference as part of this sort of industry consortium that used SMB and other protocols too. And suddenly Tuxera started showing up. And I was expecting them to be just some sort of, startup doing stuff. But it turns out they'd been in business for a long time, making these embedded systems for automotive industry, for aerospace. The space part turned out to be pretty interesting.
That is quite cool. Yeah, so they're in satellites, right? They're in satellites.
Yes.
They're on the space station.
Yes.
And on the Mars rover.
They're the Mars
Which is
rover.
crazy. Our software's on another planet.
We make a lot of embedded file system stuff. There's an NTFS from this for Linux. There's all sorts of different interesting, storage is what Tuxera really drives deeply into doing is the storage, whether it's where the file, sits, or how you get the file to and fro from wherever it sits, which is where you and I come in. And it's a super interesting portfolio of products. But of course, I just care about Fusion.
When we joined Fusion, I think there were certainly some surprises. I mean, from the media entertainment side, the main reason I wanted to come was for the performance. For me, it was all about performance. It was about the whole multi-threaded, multi-node, extended cluster environment, and certainly from my previous role, I wanted to be able to get past 3 or 4 servers clustered together, and that was a limitation that I had using Samba.
Right.
But now we can go, 30 plus nodes, which is fantastic. So for me, it's about performance, and that's what really drew me into it. What drew you into? What did you find drew you to Fusion?
But I mean, for me, it was about being able to really take SMB to both extremes. We made SMB on Windows, and Windows is a very general purpose operating system.
Yep.
But it's strictly proprietary. What you see is what you get. So you have Windows, and you can't really subtract or add very much from it. You can't make it very small, and you can't make clusters that are very big. And so what was really interesting to me was I was reaching the limits of what I could do with SMB in Windows as far as scenarios. I couldn't make tiny IoT. I couldn't make containers. These were limitations of Windows that prevented me architecturally from doing these things.
Yeah.
And I couldn't make gigantic mega clusters to the opposite end of the spectrum. I couldn't make tiny fleets of a zillion little SMB servers, and I couldn't make a really big cluster.
A really big scale-out cluster.
Yeah. We had invented the concept of scale-out and continuous availability and RDMA and all these things, but we were hamstrung by other areas of Windows of which we had no control.
Yeah.
And the thing about Linux is it's very flexible, and sometimes that can be a real pain point, but also it's, for the most part, super easy to just subtract what you don't want, add what you want, and get very large and very beefy, or just get down to this minimal little nubbin of an operating system. And it gave me all sorts of visions for the future of the protocol that I honestly could not do in Windows. It is prevented from doing for architectural reasons, not just because somebody there didn't care. I mean, I did care about it very much, but I couldn't fix it. It just wasn't possible with Windows. And so I wanted to be in the mix there with the future of SMB, for the rest of my career. I spent all this time improving this protocol with SMB3 and making it more and more safe and adding more and more functionality, but I was sort of reaching my limits at that point, where no matter what good idea I had, I wasn't going to be able to do anything with it.
Yeah.
That's what drove me to consider something like Fusion and coming to Tuxera.
Yeah, it's interesting, and from my side, talking about the performance, that's what drew me in. But when I started to talk to them about more deeply about Fusion and about where it could sit, and certainly since I've been here, I've discovered how I think how flexible it is. Is probably the best way to put it.
Very much.
And this is something we're talking about at the moment a lot more, because you can deploy it in so many different environments. When we say you can do a single server, or you can do a 30 plus node cluster, that's great. But single server or single instance doesn't just mean a box of hardware running Linux
Right.
and you throw Fusion on. It could be a container, right?
Yeah.
It could be 1,000 containers, but they're all single servers in their own right. So that flexibility, and then cloud as well.
Yeah.
And the other side, it's hugely flexible, and the performance for me is pretty astonishing.
That's the best part. You get to the gigantic. I bought 32-node cluster and I filled it with hardware and NVMe and RDMA and everything is the fastest thing ever.
Yeah.
I can actually utilize all of that. Like I can buy as much hardware as I want and as wide a pipe as I want and expect to get my investment back, which is not something that I would be able to do out of Samba. But we'll talk about that more in a bit. But also, I can go down again to the small sizes and not make sacrifices on performance. I can still use RDMA. I can still have domain joins and Active Directory and all these things down at this tiny scale you might use in a microservice or in a giant swarm of Docker containers or Kubernetes or a bunch of IoT junk devices just lying around, little tiny IoT devices that whatever you have, you will get the best performance that hardware can offer. You're never going to be sitting there like you had been in the past, for example.
Yeah.
Paying for something and only getting about half of it returned, as performance on your investment because it couldn't be addressed. And that's the nice thing about Fusion is you end up being able to get everything as good of hardware or as bad of hardware as you want. You'll never get anything less than the performance of whatever the hardware offers.
I think it's important to point out, that when people are looking to provide an SMB server, so you've got a lot of connected clients, whatever they may be. They might be Linux systems, Mac systems, Windows systems, maybe systems are running like a Windows embedded, but they use SMB because it's built into it. You can't install anything else because it's locked in. These things need to connect to storage systems. So what are your choices really? You've got Microsoft, obviously. You've got Samba, which is open source version, allowing you to connect through open source. And then you've really got us. And I think looking at those three in their own right is important.
Yeah.
Because Microsoft clearly has its values. And if you're a small company, you want to have a small server running a few connected clients, you can have a Microsoft server in there and it'll do everything you need, including a Windows share, and you can put some disk inside, But it will have its limitations from a larger scale. And you can have Samba, and Samba's a great tool. For certain environments, it works perfectly well. And I've grown up with Samba in a way of saying, but it does have its limitations. And I think where we sit is that you've got all of the things that you get from other people, but so much more. So you have the performance outside. So we can sit on Linux like Samba does, but we are way more performance. We've got more scalability than Windows. And that's really interesting to me, all these things that I've discovered since I've been there, like you touched on SMB compression and all these things embedded in there. And I didn't know how good SMB compression was, for example. And you've done this great blog post on it, which you're very proud of. And well, it's true. I mean, showing the actual figures and you go, wow, that's ridiculous.
It's been so hard to get people to realize that I did compression like several years ago.
Yeah.
The problem for me is always, around just letting people know. A lot of times people think about SMB and their experience with it is, I used it a long time ago, and they don't think that there's really been a constant revision and improvement and modernization, because they might have used SMB back when they first started using Windows, for example, which could have been 30 years ago. And as they keep going along, we had SMB2, and then we had SMB3. And SMB3, honestly, the SMB name there is almost more like brand recognition, because its similarity to SMB1 is they both use the same port and they both make files go back and forth, but they're so incredibly different. You could have changed the name and people would have been like, yeah, that's legitimate. If we just talk about the Windows side, like why I like Fusion, in a stack up with Windows, there's a few things that I really. First off, Fusion is a licensed patented protocol holder from Microsoft.
Yeah.
So
that's important.
It's really important because that means is if I buy a Fusion license or a bunch of Fusion licenses, I'm getting from a company that is licensed by Microsoft. The patent protections are there, but it also brings a lot of peace of mind in the sense that, as Microsoft keeps developing the protocol, and I'm not sure if they'll keep doing as big a things as when I was there, or maybe they'll just do more maintenance, whatever. It doesn't really matter. We keep up. So right away, when you look at Windows and Fusion, and you look at the progression of features, we at Fusion trail behind the released feature list, usually by just a couple of months. And we've been maintaining that close follow for 10 years, 10 years now. And part of our real mission with Fusion is to say, you're not running Windows, you're running Linux. So it's not like it's a competition with Windows in that case. It's just you're using a different platform.
It's a different environment.
It's different
deployment.
Like Windows, hate Windows doesn't really matter. It's just using Linux.
So that's exactly the point, though, isn't it? I mean, looking at the SMB patent license, and you were saying that you've got the Windows side, and we're not really in competition.
No.
Well, so I suppose we are.
We are in competition in the sense that Windows and Linux have are fighting over the same markets and the same customers and stuff. But we're not in that space. We are just in the Linux space. And if you're using Linux, we are offering you the technology of SMB that is as good as the one from the creators of SMB.
I think that's the key thing, isn't it?
It's the key thing.
It's the key thing that we're on a level with what they're deploying.
Yes.
And the storage partners that we already have are very safe in the knowledge that what they're deploying is so closely behind Microsoft.
Yes.
Should Microsoft change something, we're right there and we're
Right
updated and we're compatible.
And also, and this sort of hurts my own feelings, as I came to Fusion and I started learning the product, and I got my hands very dirty for a few months, and I started doing my own little sort of bake-offs against myself from my prior Microsoft days. I would find that you have the same feature set.
Yeah.
I would actually find that my performance was better in Fusion. Between Windows and Fusion and Windows and Windows, I'd do these tests, I'd run them all on Hyper-V. I would give Microsoft every advantage.
Yeah.
And then the actual just raw throughput, the raw IOPS, the raw copy a file, open a file, all that stuff, I was faster than the Windows machines. Exact same hardware. Everything was the same except operating system. And it's not because somehow magically the SMB on Windows Server is slower. It goes back to that problem of Windows. It is a monolith.
Yes. Yeah.
With a bunch of stuff in there that you have no control over. Filter drivers, antivirus drivers.
Well, that phrase bloatware comes into mind, doesn't it?
I mean, let's be a little nice.
But you know what I mean? It's kind of...
There is a whole bunch of
so
stuff.
much
There's so much stuff in there, even on a server, which is only purpose is to be a file server. That you can't, it's networking stack, it's kernel, memory management. Yeah. There's a whole bunch of, without getting into NDA pieces, there's a whole bunch of stuff on there which is just going to make it, whoever is doing whatever sort of competition of moving data, the Windows one is just going to be a little bit slower. And there's nothing you can do about
it. It does have so many more jobs to do than compared to, and that's why storage manufacturers like Linux.
Yeah.
You've got running things like IBM Spectrum Scale that runs on Linux because the core operating system server is just lean and efficient, and you only need to put in what you need to put in to get it to do the job you want to do. Yes. So everything that goes into it should also be as efficient.
Yes.
And I think certainly from my discovery from M&E at the moment, and also talking to some of the medical customers as well. We've got this great case study with a college over in America, and it's a familiar background. It's storage servers, it's cluster, it's loads of Mac clients. So it could be media, in effect, with the physical connections and the workstations, but the workflow is medical. But the same problem arises, that it's about efficiency and about making sure that all the connections stack up and they can be run simultaneously and it can cluster properly in two locations. So I think that efficiency of Fusion is something that really surprised me.
Yeah, that's the thing is Fusion itself can be run in both kernel and user mode.
Yeah.
And usually when you talk about the differences across any sort of remote file system product, across any sort of distributed system, you say kernel's fast, user mode is flexible, right? You'll make your choices based on the ultimate speed difference versus, the ultimate sort of flexibility, ease of use, management, etc.
Yeah.
But here's the problem with Windows. Windows is always kernel. You cannot do user mode Windows SMB. That causes two problems. One, you're always living in however fast the kernel can work. Two, in the Windows container model, things that are in kernel are not allowed to be in containers. The separation of church and state inside of Windows is extremely strict. So if I have a server service which runs SMB, you cannot have it be a container. It is not allowed by the architecture of Windows.
Yeah.
So when the first time I ever recommended somebody buy Tuxera was 4 or 5 years ago when I was a PM at Microsoft, and somebody came around from the cloud side saying, "Hey, we'd like Windows containers, which are a thing, and we want to use them, but we don't seem to. How come the file server doesn't work?" And I'm like, "Well, that's just because of the architecture.
Yeah.
You can't do it." And for us to, at that time, to provide that would have meant writing an entire other version of SMB in user mode. And so with Fusion, what's funny is almost all of the actual production use, and it's production on hundreds of clusters, tons of systems, unknown countless systems, mostly in user mode.
Yeah.
Because the performance is actually incredibly good. And in fact, if you ever look at my container blog post where I have to explain all this and then I have to sort of jab Windows a little bit saying, I couldn't compare you here because you don't have a story. But I did bring up a regular Windows file server just to show performance against the containers. And the Fusion user mode container was faster than the dedicated kernel Windows server for the same workloads. So you're not really paying any real price with user mode or with containers. You're not sacrificing performance. You're just gaining flexibility and a modern workload and something that can move a lot of data very, very fast with very low latency in the Linux world, which is where containers are. Linux dominates containers, dominates it.
I mean, storage is changing so much as well. You've got, not only have you got people using on-prem storage, but obviously working either remotely or connected offices, and then there's cloud deployments as well. So, it's changing a lot, and being able to have effectively the same binary just running here, there, support levels are going to be a lot easier. Deployment's a lot easier, because you are deploying the same set and the same set of tools, and those tools that we have can be deployed in the same servers as well.
Yeah.
So you could have SMB compression potentially running in a cloud deployment.
Absolutely.
And you think, well, that's pretty cool.
Yes.
And compression for me, I thought, well, that's great. It's just stripping out the zeros. So you take a file and again, I think you've done a demonstration on this as well, and you're talking about transferring like a disk image file.
Yeah, I used my home cable, the worst monopoly broadband in the world, and I was able to copy files with 90% reduction in time. The same file with or without compression, just 90% less time spent.
But that's huge for transfer. I mean, for business.
The productivity of, I'm sitting here watching a progress bar for the next 20 minutes as opposed to just 2 minutes.
Yeah.
Like that's real dollars and cents, your end users and applications seeing a real benefit from SMB, the protocol, that they would look at and say like, boy, this is awfully fast. And they don't have to think about, you have to teach them why, to make them do anything, it just happens.
But I think that's quite key though, because that talks about, our vision for Fusion, which is effectively we want to be the best SMB server available anywhere.
Yeah.
And I think we're pretty close to that, to be honest. Some of the stuff that we've got going is fantastic. But the SMB compression side of it, if you are in any industry where you're transferring large files where some of it or a majority of it could be empty space, you think about medical, maybe they're transferring, DPX files or EXR files or image sequences. A lot of those could be compressed.
We talked to somebody, one of our customers, we talked to them about They run a bunch of gigantic scanning electron microscope stuff. They're like a research
Yeah.
university. And as usual, that no one had heard of compression. Maybe we should like have a billboard or the blimp that says there is compression in SMB. But they were like, oh wait, I mean, we know this file format we use for this gigantic, many, many millions of dollar microscopes. And they scan stuff and they create what amounts to being just gigantic picture files.
Mm-hmm.
And we know that they are as raw and as uncompressed as they can get. And we know that if we zip them, they get considerably smaller. Mm-hmm. So we just tell our R&D folks and stuff, if you want this to go any faster, just when you're done scanning somebody's DNA, whatever they're doing, just zip it and then put it on the file server. That just goes away. You just tell them to just do what they're doing, save their file.
As you do.
And then you don't need to teach your users what compression is or
but think of the time saving.
Yeah, the time savings is
you've got to zip the file to start with.
Yeah.
Then you've got to copy the thing, and then you've got to unzip at the other end when you need it. So
yeah. Well, there's steps that you're going to miss, or steps where you don't want to have to teach them how to do stuff. Now it's just magically they come in one day, and it just seems to be a lot faster. Like it's just like something good happened with my IT department, and I don't know what they did. But
what the hell happened? Over the weekend, we installed Fusion.
Yeah.
We put it in and off we go.
That is basically how it worked out. Yeah.
And the other thing that I was quite pleased about, we're heading towards one of the biggest shows for broadcast NAB, and we're talking about our optimizations there. And one of the things that we touched upon is this access-based enumeration, which I have to say slowly. AB is a lot easier. And I like the idea of what that's doing. And the way that it's hiding files and folders that you don't have access to, because one of the biggest things you've got is browsing massive folders is the amount of time it takes.
Yeah.
And certainly when you've got confidential information and valuable IP sitting on a server, and you've got different groups working on different projects, with the ACLs, if they've locked access to those folders, they just disappear, as opposed to being seen and going, oh, I wonder what that is. I can see the name, I double click and go, oh no, you don't have sufficient rights. And they just disappear, which is a great security feature, and so much faster because it just browses the files you have access to.
That's a funny thing too about the fastness. This is another spot where in Windows versus Fusion is better. Access-based enumeration (ABE)
actually so much easier.
ABE came around. It came around actually in Windows Server 2003 R2.
Wow,
it was a feature then. It was done in competition to Novell NetWare, which still was an actual serious market competitor back then, if you want to feel extra old today. And so we're talking about 2003, 2004, 2005 timeframe. But the implementation in Windows is actually really, really poorly done. Not because the developers were stupid or bad, but because they didn't have an architecture, again, that they could rely on to make it efficient. And so when you run ABE in Linux on Fusion, I'll give you this. In Windows, when I created the Windows Admin Center extension, which is the management tool you use in Windows to manage everything, I mean, a whole bunch of stuff, but there's one for file server in there. I hid the access-based enumeration button under like 2 clicks.
Buried it deep.
Like I buried it like that because as soon as you turn on ABE in Windows, your performance in a very large volume with a lot of folder structure, a very flat folder structure, it really, really tanks. And Fusion has just done a better job of leveraging the Linux storage systems, VFS, our virtual file system layer that lies on top of whatever your real file system is. And our own general coding of Fusion. It's a thing which you can turn on and not immediately feel
not panic too much
impact.
Yeah.
Not in any way that users would probably perceive. I mean, you could measure it very carefully and say like, oh yes, this is slower now, but not in a way that a user could notice.
You're not getting 100 users 9 o'clock in the morning going, what's happened?
And I mean, this is a really important security feature. I mean, honestly, this honestly should have been the way that Windows always worked, because it just, you're hiding metadata. So you have an access control, like you said, that says like, well, you can't open this folder, you can't open this file, whatever. Yeah, but the name of the folder and the file is, third quarter mass layoffs dot spreadsheet. I mean, that's something you probably don't want anybody to read about, or giant marketing plan coming for secret project X. That's how those things get named. Well, that's not great.
You work for Pepsi and you start seeing the word Coke appearing on the first. Yeah. No, we don't want to see that.
That's not ideal. So yeah, this is it's an important feature, and it's another one of those things where I feel really good that your Fusion experience will be better than your Windows experience, even though ostensibly Windows should be way better because it was invented by Microsoft. Yeah. But like I said, we're not really necessarily in some battle with Windows.
No.
There are our real intersection in the market right now, arguably, is Samba, and that's where we do some things that I'm pretty proud of, and really expecting our future to be very good, because Samba's been around for a long time. I mean, Samba's as old as, not quite as old as Windows NT, but I mean, it followed along pretty quickly behind it. So it's, Windows 2000 just turned 25 last week. Samba's been around for a very long time. It's a very mature product. It is definitely a much older product than Fusion, which at a mere 10 years of time, it's closer to 30. But that also means it was written and designed, architected and built for that time. And that time in 1997 or 2000, for most computing, having 10 computers was a lot of computers.
Especially networked in any way.
Networked together in a work group?
Yeah.
That's crazy
Some
talk.
central storage?
Yeah, that's crazy talk. So, I mean, Samba's a lot of stuff. We say Samba, when we say Samba, we mean the file server, SMB. I mean, Samba is actually a whole suite of products. It's a domain controller, emulator. It's an old NT4 domain controller emulator, an Active Directory domain controller emulator. It's a whole bunch of products. But from the SMB side, it was written for a time when it was easier and safer to write your applications to be process-based. So it's not a multi-threaded server.
Yeah.
It's a service, a daemon or whatever it's called in the world of Linux, a service running that makes lots and lots and lots of other services run on the fly.
Yeah.
Each one of those is a file or a client connecting or a handle or they're all processes, right?
Yes.
So if I've got 10,000 users connecting, I have at least 10,001 processes running. And as anybody who's got even the gentlest knowledge of how CPU architecture works, a process is much heavier than a thread. It consumes far more memory. It is something which is much harder to do with threads. And I remember reading some interviews with the Samba team where they were talking about, being asked if they would switch models. And they said no. And they haven't. Those are old interviews. To this very day, it is still that same model. So when you were talking earlier, you talked about I could only get to a certain amount of performance out of Samba, no matter how much hardware I threw at it. And no matter how much memory and CPU, you might now have a Marvell or a NVIDIA or whomever, these companies buy each other up all the time, RDMA capable NICs. So you've got all this bandwidth. Now your storage is way faster because NVMe has come along. And obviously from the old days, there was hard disk drives, then there were SSDs, flash. But there's NVMe, which is still flash, but now with a much better bus. There's NVDIMM, which is basically just RAM being with a battery on it, being your backing storage for caches and things. And so the storage has gotten incredibly fast. The networking's got incredibly fast. Those used to be significant limiters where if your SMB, your remote file system, NFS or SMB were slow, like no one could tell because you were never going to crack the limits of the storage and the networking. They were already so constrained. And as those things got faster, they started exposing the problems of a slower, lower performance, higher latency remote file system like SMB. Well, we talk about it with Windows. If you give me 100 gigabit between my Windows machine and my Fusion server, and you've got storage that can handle the IOPS, I will do that 100 gigabit. I will do 12 gigabytes a second on that network because SMB3 really SMB2, but SMB3 and Fusion are efficient enough, capable of actually utilizing that full set of bandwidth. And unfortunately, no matter how much hardware you throw at your Samba backend, it's not going to matter because it's basically capped.
Yeah, it's capped in a number of processes because it's very processor heavy, of course. The individual performance of the client, like you said, is the Mac 2.8, Windows 2.8, around that kind of level. So a point to point, you're kind of limited at that scale.
Yeah.
On the back end server side, you can get faster. But again, it's still going to be capped out because of the number of processes and because it's processor heavy. So you've got an awful lot of hardware. And certainly in my previous role, we had not only central servers, but we also have what we call gateways. And this is used quite a lot in the industry where you're offloading the SMB sharing because it's processor heavy, because effectively it's running the Samba side. Yeah. So you've got a big storage system and it's really quite powerful. And then to take the sharing, if you think about scale, IBM Spectrum scale, they can take off their GPFS clients to a piece of hardware on the outside, and that then does the SMB sharing.
Right.
So you can have a number of gateways around the outside, all pulling from the very fast storage in the middle. But each of those gateways is going to be limited and things like that. So one of the things that I, certainly talking to the engineers in the office and talking about the performance side, is understanding that you can put in the Fusion side, you can strip out the Samba and put in Fusion, and then suddenly all that bottleneck that was sat there is gone because we are going straight through. Now, whether you're using a multi-threaded connection with the SMB or you're doing RDMA, you've got that balance. You can do the two and you can run them, and you've got the best choice available for your environments. And I think the Mac thing is quite key. Macs are vital in media production and in education and used a lot in medical. And a lot of companies you go to now where they'll say, well, do you want to use a Mac or a PC? Here we've got a mixture. We're all working on the same systems. We're using 365, we're using the same environments, but the workstation you've got a choice over. And they can be just as secure. But in the media world and the production world, they are used side by side. But there's always been a limitation. And I think from the storage side, if you want to get performance, SMB could never deliver what you wanted. And of course you've got AFP, which is Apple File Protocol.
That is fried chicken now. That's been gone for, Mac decided.
But it's still being used though.
But Mac decided basically Leopard or whatever these goofy names are. They decided to just basically abandon their own protocol in favor of SMB. And for almost the last 10 years, SMB's been Mac's answer for, connectivity to Windows, connectivity to storage. And they just basically threw up the white flag and went with SMB.
Yeah, it was. There was the point, it was 2013, I think, when next software release came out, and you used to be able to just open your connected server, type an IP in and hit go, and it would default to AFP, and it would fill in the AFP bits, so you didn't have to put the addresses. And then the release came out, new version came out, Mavericks, and then it was SMB. And it was so you'd have to type in AFP if you wanted to use AFP. So AFP is actually a very good protocol, and you've got open source versions like Netatalk, which delivers AFP. So storage manufacturers they can put Samba in, they can put Netatalk in. They've got SMB and AFP, which is fine. But to get real performance, you'd normally have to go to a connected client like a SAN client. So you'd have like a StoreNext client or potentially a GPFS client, which never worked on Macs. But that kind of thing, you'd have to have a native client, and native clients would introduce problems on the client workstations because you'd have to install this extra software. You'd want to make sure your workstation's on the same version or as close as possible. And the fact that we can now deliver over 5 gig a second on a Mac is really, really good because there's certain workflows in media where you want to be able to use Linux, Windows and Mac side by side and all on the same protocol. You don't want to be messing around too much.
It is impressive because, like Samba, Mac does not do RDMA.
No.
So squeezing 5 gigabytes a second out of TCP, not multi-channel aware at that point. You can't use multi-channel if you don't have more than one NIC on a Mac. It's actually quite impressive that it was able to be gotten as high as 5 gigabytes a second because Windows is cheating. I will do multi-channel, I will use receive-side scaling hardware, I will use your RDMA networking. It's a lot of that performance boost from Windows is actually not I mean, Microsoft is making it happen, but it's really just offloads and additional channels being offered by the metal. And so Mac's doing it all in its own head, all by itself, and it's actually quite impressive that they get, that much performance out of it. And 5 gigabytes a second is a lot. I mean, all by itself, that's a lot.
Yeah.
But the media entertainment space extremely well. I mean, how does SMB fit in there?
But where SMB sits in media it's open, and all these things like SMB compression and ABE, and the performance side of it, and the scaling, and the the multi-node clustering. That's where SMB can really help.
Well, it's the one that is the only one that all the clients actually speak to very well.
Yeah.
SMB is the one where the experience across the board is going to be super fast as that operating system will let it be. And it is an open protocol specification. So it's not, SMB started off being very proprietary to Microsoft. It is not anymore. Everybody offers SMB. All of your old style, very expensive NASs do SMB. All of your, little tiny devices you buy at a retail big box store, buy personal storage box, they all use SMB. It's the only thing that works across everybody as fast as anybody can go. It really is the great unifying protocol. What does that mean for media? I mean, I assume that when somebody makes a movie, that they have a bunch of cameras and they roll and they capture an enormous amount of footage, enormous quantity, terabytes and terabytes of footage that has to go somewhere to be shared by a bunch of people to do post-processing to turn it down to the hour and a half of the movie. And I assume that you probably have some known ratio of hour and a half of movie equals thousands of hours worth of not movie that we have to go through. But you have to have it. The data's got to go somewhere. Is that where SMB is bringing the advantage here?
Well, when you talk about sort of the ratios, it depends what you're filming, of course. If you're filming reality TV,
yes,
like Love Island or Big Brother or any of these kind of things, your filming ratio is enormous, right? Hours and hours of footage for 1 hour broadcast every day, and that's got to be stored somewhere. And we talked earlier about codecs, that way of compressing and encoding the video that you're taking, you're shooting video and putting it into a file and using codec to encode it. And I mean, media is one of those places where industry standards are. We've got thousands of industry standards. So you click on the Argent of things, and you've got a list of codecs a mile long, and they all have different data rates and different performance rates. So this in turn makes media production absolutely chaotic. And if you're using on-premise storage, then SMB will sit very nicely with that, because certainly with Fusion, you've got the safe knowledge that the hardware that you're buying is going to absolutely put all that performance out to the network. You're not going to get bottlenecked. You're not going to have to stack up loads and loads of disks as much as possible just to try and get it through the network.
Right.
You can produce the same amount of performance for less hardware in effect, which reduces overhead, reduces power consumption. It's better for the planet, but it's also better on the pocket. So it absolutely makes that better. But in terms of production, you've got cloud production, you've got remote production, where are those files going to go? And you need to be able to talk to different locations. So there's various options for cloud production. So you could do everything in the cloud, which means you're going to need cloud editing, you're going to need cloud production. So if you're running editing systems in the cloud, you're going to need access to file shares, which means, again, you're going to need SMB to connect to virtual storage systems and virtual machines and storage in the cloud. But you also want to be able to connect from your location as well. So where SMB sits in that, and where we sit in that, is because we talked about it earlier, we can be deployed wherever you need it to be, and we can be connected in that way. What SMB, particularly if you're going to be using a lot of performance, I think now, genuinely, we've got the option that you can deploy what you need. So if you take, for example, film scanning, so a lot of old films are being scanned in, and some great manufacturers of film scanning, and they're doing...
You mean like film,
actual
like
proper
celluloid
film.
being turned into digital images?
Yeah,
okay.
Absolutely. So you've got rolls of film, and they're running through. Some manufacturers got a thing called wet gates, so they run them through liquid, which then removes the scratches before they get scanned. and they come out and then get rolled back again. They get dried and rolled back again.
That's
so
pretty cool.
It is very cool, especially when you see it in action. But that environment inside that box is generally a Linux server running the hardware, and it's got to write that to storage. And they're scanning maybe at 10 or 12 frames a second when they're doing overscan with alpha and alpha channels and things. What that really means is they're writing sequential files that could be 130 megabytes each at 12 frames a second. So every second, 12 files are written in sequence. You think, well, that's actually not too bad. That's not too much performance.
1 gigabyte?
Yeah, and you think, well, that's okay.
Okay.
But then you have the retouching workstations and the color stations and the restoring workstations, which could be Mac or Windows or in fact Linux. But they want to play that back at 60 frames a second. So now you've got that same sequential data being pulled back at huge volume. So for us to be able to deliver 5 gig a second to a Mac Pro running Resolve, where they're doing color work on it, that's fantastic. Because you can have the same storage. Everyone can be using the same storage without loads and loads of different protocols all flying around. It can all work together. And that's probably the same for, if we're looking at medical, we've got these body scanners and things like that. They all have to put these files down onto storage systems and then read back. So I think SMB does really give us that flexibility.
That is the thing, right? I mean, the only thing I've noticed, I spent many years working in Active Directory and security and identity before I became a storage-focused, program manager, and then what I am now. It didn't matter how much better the storage got, how much faster, how much bigger it got, how much bigger the networks got, how much faster, and how much more throughput they got. Somebody would invent much bigger files, and you would never get ahead of it. I didn't even know until I came here and started talking with you about stuff that there was 8K. Like I had just missed the notion of yet again, the fidelity had doubled from the one that I thought was, the one that I heard about, 4K, the thing that you use with Blu-rays or you see at a really fancy movie theater and stuff. No matter how good your networking and hardware storage gets, somebody will invent just. It's like a bet. I bet I can use up your storage and network faster than you can increase the bandwidth by inventing gigantic, massive files to fill it. So you reach that point of, with something like a Samba, where it becomes a productivity hit. It becomes a measurable amount of money you're spending with some, I presume, hourly people working in post-production who are highly compensated craftsmen and technical experts, artists, where you don't want to pay them anything except work, not standing around. I can only imagine what just the production costs of a half-hour TV show must be just for the amount of people behind the camera. The ratio seems to be 1 to 50 or so of actor to people making it all happen. And so when you think about, where's the savings of doing something modern like this, part of the savings sounds like just not sitting there waiting for things to happen.
Well, yeah, but it's also, if you think about it, you've got very highly skilled production staff, and that's an hourly cost to a business. Right, and what they're producing in that hour is also invoiceable, right? So the company has to be able to invoice that hour out.
I see.
So if they are, like I said, wasting time waiting for things to copy, for example, if you have, I'm going to say Mac workstations, because really there's a lot of Macs out there, and they are used heavily in production, and they are the favoured tool for a lot of creative people. And unfortunately, because of that, there comes the limitation of the performance. And then if you're thinking, right, okay, I need to build a production company and I want 10 Macs to be able to get this performance, I've suddenly got to think about all this huge amount of hardware to be able to deliver that. And of course you can ramp it down, you can use codecs. So people talk about using something called a mezzanine codec. So they'll encode everything down to the same file format, which would be less files, smaller files, so they can work on them. But when they come to do what's called, conforming, or putting everything back together to produce a master, they then have to go back to using the originals again, which sort of unpacks this whole data requirement. So, you bring it down to work on it and bring it back up again. That's because normally the investment in all the hardware to be able to just work off the product and not have to encode it all down, which is time, and then decode it back up again. being able to do that and be able to run at this high performance means that you don't have to copy files to local workstations just to work on them.
Yeah.
You know, if you think, well, I'm going to work on these this image sequence, these DPX files, which is what's used on lots of the high-end color touching, I need 4 gig a second or 4.5 gig a second to work on these files. That's the data rate that I need.
Right.
But my server can only do 2.8 to my Mac. Right, so you have to copy them to the local thing. Then you have to have a workstation full of NVMe. And then you have run the files locally and you do what you need to do.
Yeah.
And then if you make changes to those files, you have to put them back.
Yeah.
If they're using a reference, you don't, but you still have to copy them.
Yeah.
So breaking that barrier, which is what really got me interested in Fusion to start with, is that breaking that barrier. You know, we had a potential customer that said, look, if you can do 3.8 gig a second, that's it, we'll just buy your system. And then we cracked 5, and it's like, this is fantastic.
Yeah.
So now they can just we'll just work on it. And the thing is, it's just SMB. And I'm not trying to downgrade SMB, but it's just SMB, which means it's built into everything, and you can just go connect up the relevant cabling, and you go connect to server, put in the IP address, whatever you want to do, boom, up you go, work.
Yeah.
No extra software, no licensing, no weird stuff in the background. You don't have to install special configurations on the machine. You know, with GPFS, putting a GPFS client onto a workstation is a messy job.
Yeah.
Because you're joining the whole storage pool.
It's like the days of fiber channel arrays and HBAs and the SAN days and stuff, where you basically would use block storage and things and just be carving things out and using electricians to set up your network. Not network specialists, but actual, electrical engineers, because the whole thing was just an entirely complicated point-to-point, system.
But that's what we're doing back in the day. In sort of 2007, 2009, SAN was still the thing.
Yeah.
You know, because what option did you have? You could build your own server, and then you could use, and the processes weren't that fast. The drives weren't even that quick.
Yeah.
You know, and because it was a NAS, the server was doing all the work. And I think that's the key thing with the SAN. The workstations help the SAN out.
Yeah.
They help buffer the storage. They help work with the storage. It becomes a whole big storage system.
Yeah.
So they all help each other. In a NAS, invariably, and that is effectively what every storage system running SMB is. It's a NAS.
Sure.
The server has to do all the work. So that request comes in from the network and it hits the storage through the NIC into the layer. The server has to do everything: find the files, seek them, pull them off the RAID, push them out through the NIC, out through the protocol, and deliver them. The client's just going, yeah, I'll just take it. So that part where we're really, really efficient is unlocking that side of it.
Right.
And particularly with RDMA, bypassing the CPU completely and going straight to storage is fantastic. It's almost back to block days, if you think about it, but it's not. But it's that kind of logic that the workstation is working directly with the storage.
Yes.
Directly with it. Even though it's not running as a block storage.
Right. I think in technology, I think that media and entertainment really is one of those real cutting edge spaces where new things are happening. And of course, new generally means bigger, harder to deal with, bigger files, infrastructure you've got to keep up. And that's something that's going to be where Fusion really helps, because as the hardware grows, as the files grow, as the networks grow, Fusion is able to take advantage of it, and you don't need to do anything. You just add your hardware, and Fusion's like, all right, thanks.
So yeah, it's interesting. So yeah, thanks.
Yeah.
So I think we'll wrap up. It's been a great chat, good conversation. So thanks, Ned.
Thank you. I really appreciate it.
Good stuff.